Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Aizat Abadi bin Abdul Hadi with my friend Muhammad Lokman bin Yusuf and Muhammad Rizal bin Zazi. My friend and I will presenting our high voltage technology laboratory entitled AC high voltage generation and measurement.
For correct apparatus for hypothesis, uh, the type is PZT 100 to 0.1. Exclusion test transformer 100 kV, 10 kilovolt ampere. To that, CM measurement capacitor, ES grounding switch, EST discharge rod, EL top electrode, KF spare gap. To that, V connection rod, K connection cup, FS floor uh, pedestal, and lastly is SEK. AC is a secondary part of part for CM AC. And that the connection circuit between FC to transformer tap point. This is the circuit. Uh, this is the frequency converter to the uh, transformer. Okay.
What is voltage divider? Voltage divider is in this experiment divided by 2, which is measuring capacitor and secondary AC device. Measuring capacitor, which can be used as HV unit, which is high voltage unit for the AC voltage divider, which capacitance is 100 picofarad and max AC voltage is 100 kilovoltage. And the second one is the secondary AC voltage secondary unit for the AC divider, which incorporates the LV capacitors. Next, connected between the HF socket of the measuring capacitor CM and the DMI 551 or picoscope by means of coaxial cable. Coaxial cable is used to conduct weak or low amplitude voltage signal due to its excellent ability to shield such signals from external interference. The coaxial cable is only able to sustain 7 VRMS. Capacitive divider main goal is to sustain high energy. Each secondary device has different serial number, settings, and calibration value. So make sure the serial number value is the right one. This is because we need to refer to a manual book in order to obtain the divider coefficient value to set to the control system. The serial number of the secondary AC device used is 22341076-04. Next, I will continue with the connection of basic components from transformers to the capacitor. So we started from the transformers here. It will connect it with the measured capacitor by using connecting cup. This is the connecting cup and this is the top electrode. After that, for the connection between capacitor and secondary AC device, we use male-to-male connector. For the secondary AC device, we need to connect the grounding by using banana to female connector. After that, for the grounding connection from the capacitor and secondary AC device is connected by using grounding connector, and we use double protection. By using double protection, the system will be more safe. As you can see here, the grounding is connected from transformer, measured capacitor, and the secondary AC devices. The ground switch must have contact with top electrode. As you can see here, this is the top electrode, and the ground switch must have contact. It must touch the top electrode. And the last but not least, the connection will go to the control system grounding. So I will continue with the capacitive divider circuit, which is the answer for the question 2.4. So as you can see here, we use the measured capacitor of 100 picofarad and the secondary AC device of 2 microfarad, and the connection are in series. Since the measuring probe only allows 7 VSC RMS, so this is the suitable capacitive divider circuit, as you can see here. Next, I will continue with the schematic structure of the secondary capacitor. As you can see here, this is the structure of the secondary capacitor, which consists of 21 capacitor and 1 resistor. There are all the capacitor are connected series and parallel to the voltage, and the resistor, which is 10 k ohm, and the grounding is here. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Luqman bin Yusuf. I am now continuing explain about the connection. First, it is transformer and will be connected to the capacitor, and then with the secondary capacitor, and then to the regular DC. Next, I'll be explaining about the construction of the coaxial cable. In this experiment, we will be using the BNC coaxial cable. I'll explain about the layer of the coaxial cable. The first layer is the center conductor, and the second layer is dielectric. The third layer will be conducting shield, and the lastly is the outer layer. These are the different bit of coaxial cable. As you can see, there are a lot of type of coaxial cable, and the arrow is we are using in this experiment. The purpose of coaxial cable is to transmit electrical signal from one device component or system to another. Coax cable are distinctly recognizable due to their heavy construction. In addition, this also makes them one of the most durable type of cables used in radio frequency transmission operation. The name coaxial is derived from the common axis of the cable's two conductors. In order to understand on how the coaxial cable work, we must first be acquainted with its 4 different layers. The first layer is a conductor that is typically made from copper. This conductor transmits video or data. Second layer is surrounding the center conductor that is plastic dielectric insulator. This prevents signal loss and facilitates the reduction of EMI. It also provides insulation and create distance between the core conductor and external layer. The third layer is a copper braided mesh that shields the cable from EMI and radio transmission. The last layer of coaxial cable is the plastic's external prevent damage to the internal layer. Now, I'll be continue explain about the BNC and banana. The PL259 plug is widely used as an NHF cable connector. It is a shielded form of a 4 mm banana plug. A A number of widely used plugs are based on combining two or more banana plugs in a common plastic housing and other features for ease of use and to prevent accidentally insertion in other such plugs. Many of these plugs are derived from the double banana plug consisting simply of two banana plugs spaced quarter-inch. The housing may allow the connection of individual wires, a permanently attached coaxial cable providing both signal and ground, or a coaxial connector such as the BNC connector shown in the photo. Conventionally, the tap location on one side of the dual banana plug denote the ground, shell or negative side of the connector. Two set of banana socket is connected to the both side of the secondary capacitive device. One point of the banana is connected in the middle of the secondary capacitive device and the other point is connected to the ground of the device. We can easily recognize which one is the ground point by only looking at the side of the banana. There is a label ground. First, I will be explaining about the measurement. As we can see at the regulating transformer on top of the switches, there are 6 points. As you can see, the label VM1, VM2, VM3, VM4, VM5, and VM6. The first 2 points from the left, that is VM1 and VM2, is for AC measurement, while the other 4 points, that is VM3, VM4, VM5, and VM6, is for the DC measurement. Now we continue with the grounding part. There are some picture of the experiment. The first one is ground from the transformer, and second one ground for the capacitor. Third one is ground for the secondary capacitor, and next one is the ground from the secondary capacitor to the capacitor, and the upper picture is the connection of earthing from the earthing switch to the regulating transformer. These are the full connection of the system. As you can see, they are labeled the regulating transformer, secondary capacitive device, and measuring capacitor. Clean rooms are used across several industries, from manufacturing to pharmaceutical, biotech, and university lab, to keep a space contaminant-free. However, having a clean room and using it correctly are two different things. The right clean room procedure must be in place to maintain a stringent level of cleanness. There are a few examples of clean room procedure. First one is reevaluate your layout. If you are implementing a new modular clean room, it is important to consider workers and material flow. Your employees can be the largest contamination source in a space. This will help you determine the best location for your clean room. If you already have a clean room in place, it is just as important to regularly reassess your layout with any operation. With any operation, your scope and workflow will evolve. As new people come on board, items in your lab may move or the layout of the space may change. Whether you are evaluating a new space for a clean room or re-evaluating your current clean room, here are some areas you should consider. First one is door and pathway should be free of a critical process. Second one is include a single access point. Third one is to take into account any contamination risk. Second one is know your ISO classification. While you should know your ISO classification before you install a clean room, your classification can change as well as your operation evolve. That is why it's important to make reassessing your ISO classification part of your clean room procedure when you take on a new project or unit as a laboratory change. That because every industry and every application has a different set of cleanliness requirement. Clean room classification addresses the level of cleanliness in the air according to particle size and concentration. The third one is to maintain regular cleanliness. This involves much more than a spray bottle of cleaner and rag. Clean room requires special housekeeping procedure, schedule, and material to keep surface contaminate free. That's because certain floor finishes, chemical, vacuum, mop, and sponge can actually be a source of contamination. Keep up to date on your clean room classification with help professional determine with which cleaning chemical are appropriate for your space. Fourth one is take regular air sample. Air sample help ensure a clean room environment is meet specification. Typically, either air sampler or settle paste plate are used to gauge whether any contamination is occurred. That's all for me. I will thank you.